Okay. What is ion polarization? Okay. Ion polarization is basically this is the property of negative ion. Okay. What happened when you have a positive charge? And that positive charge is called as a cation, isn't it? And that positive charge will do what? It will attract a negative ion toward itself. Yes, Zainab, can you hear me? Okay, so what we were talking about, we were talking about the negative ions, and that negative ions are attracted to positive ions. Okay, so positive charge attract negative charge toward itself. What will happen? What will be the result of this? You will feel distortion. Okay, now what is distortion? What is distortion? We could write it as distortion of electronicity. Now, what is distortion basically? Now look at it. We are having a positive ion. We are having a negative ion. Now tell me which one is the bigger one?
Miss, I can't see the screen.
Oh, sorry. Now, can you see the screen? Okay, so which one?
Yeah, I can see.
Okay, so which one is the smaller ion and which one is the bigger ion?
Positive charge is smaller.
Positive charge is the smaller and negative charge is bigger. So this positive charge has more power to attract negative toward itself. Smaller size, more force of attraction, isn't it? So due to smaller size, what is going to happen? It is going to attract this negative charge toward itself, and you will see a shape change. Distortion is basically the shape change, okay? And you will see the shape change in negative ion in this way. More pull, more distortion. Less pull, less distortion. Just keep this in mind. Getting my point? Okay. Now check, see. Smaller and
Yes,
smaller size, more pull will be there. Bigger and bigger size, less pull will be there. Now, if more distortion is there, this characteristics we call that as a covalent character. Got it?
Miss, that distortion is where they will change shape, right?
Yeah, the distortion is that they will change their shape and all electron will try to fit toward the positive ion. They will start moving toward the positive ion. See, they are start moving. See, what first happened? Electron are evenly distributed all over, isn't it? And what will happen if you will be having a force of attraction toward anything? What happens? The negative ions, like this is a positive charge and it is attracting a negative ion toward itself. That means negative ion will adjust themselves to one side. So where negative ions will move, that means you will be having a distortion on that side. Got it?
Yes, miss.
Okay. Now, what is polarizing power? Now see, this is basically this one ion polarization. This was the property of negative ion. That means negative ion was feeling distortion, isn't it? Property of negative ion. Negative ions was feeling distortion. Now we have polarizing power. Polarizing power is basically the ability of cations. Now when your cations, they attract a negative ion toward itself, an electron, and distort anion. Okay, distort an anion. So this is called as polarizing power. Now what is happening over here? That means this is the property of what? This is the property of this is the property of anion. That means now which one is going to change in shape? Which one will be the change? Where will be the change of shape will come?
In the negative one.
No. What did I wrote? Cations attract the cation attract the electron and distort anion. The first one, what we wrote, distort, see positive are attract negative ion toward distort anion.
Yes, I can't hear.
Now see. Can you? Yes, Janab, can you hear me?
Yeah, now I can hear.
Okay. In between, I think there is a problem in just 1 second. There is a problem in connection. Just give me one. I'm giving you just an example. See over here. I'd give you an example. This was smaller size, so we are feeling more attraction. Now let's suppose I am having a positive ion bigger in size, and you are having chlorine ion also in bigger size. Now see, will the force of attraction more or it will be less? The distortion
It will
of
be
negative
equal.
ion, the distortion of negative ion will be more or it will be less? Yes, tell. See,
Will it be equal?
See, no, it will not be equal. There will be a force of attraction, but it will be weaker force of attraction. Less attraction will be there. See, if you were having smaller size and this was your chlorine, this lithium can pull this negative ion more because this is in smaller size. Now the size is bigger, but still the attraction is there. Now see the difference between both. Over here on the top, you will feel a bit distortion and just this way. Just this. And if you see the down one, this is your lithium size, and this is the distortion you are going to get. A big distortion will be there. A big shape change will be there. See the shape change? Getting it? So that means if you are
Yes, miss.
having a smaller size, that means if you are having a smaller size, that means you are having more polarization. And more polarization mean that this is due to the small size of lithium. Over here, you will feel less distortion, less polarization due to what? A big size of or a bigger size of sodium ion. So if you are having more polarization, more distortion, we call that the character, we are having more covalent character. Got it? But if you are having less distortion, that means the covalent bonding will be weaker, isn't it? If the covalent bonding is weaker, then that means you will be likely to have an ionic bonding. Less covalent character. That means if less covalent character is present, you will be moving toward an ionic bonding. Got this point or no?
Miss, for distortion to occur, always the positive ion should be small, right? Smaller than the negative ion.
Always. This is necessary thing. Positive ion has to be smaller.
But then in sodium chloride, both are of equal size, right?
Yeah, both are in equal size, mainly of equal size. No, chlorine is a bit bigger, but there will be a force of attraction, but it will be a very, very small force of attraction. Okay, a very bit force of attraction. Now, this is when we are talking about smaller sizes. Now, what if we are having a bigger charge. We were talking about the smaller sizes when we were moving in the group. Now I'm moving to the charges, bigger charge. If you are having a bigger charge, what is going to happen? Like, see, you are having barium. Barium is with what charge? It is with +2, isn't it? So this barium is with the +2 ion. That means outermost shell is removed, isn't it? If you are having magnesium, then also what will happen? Still your chlorine is in bigger size. A distortion will be there. Still your chlorine is in bigger size. A distortion will be there, and there will be a shape change. There will be a distortion felt over here. Just do remember one thing. This is whole to tell you that wherever you have more polarization, wherever you get more polarizing power, wherever you get more bigger charge, and wherever you have a smaller size, they show you more polarizing power. And if you have a more polarizing power, that means you are having a strong or more covalent structure or more covalent character, stronger covalent character.
Means larger charge means larger polarization power.
Larger polarization. Larger charge means +2, +3, +4. The +4, +2, like next one. Smaller size means when they are moving in the group. Okay. Smaller size, large charge will show you more polarization power. That means there will be a strong covalent bond. Now, looking at these properties, we have to talk about stability of group 2 carbonates. Okay, now what is stability? Stable compound. Now, if you have magnesium, if you have calcium, if you have strontium, if you have barium carbonate, what happens if you move down the group? As you move down the group, will not the charges become bigger? Okay, fine. But if you move down the group, is not your size increasing?
Yeah.
So the size will increase. Will you have more polarizing power or less polarizing power?
Less polarizing power.
Less polarizing power, good. So that means if you're having less polarizing power, your compound, the carbonate of the same group, they will become more and more stable. Because what is happening if they are having less polarizing power, so they will not be giving you a covalent bond, isn't it? They will be start giving you an ionic structure, and if ionic bond will be formed, they will become more stable. Getting a point?
Yes.
Okay, so we can write this as that if you move down the group, what will happen? The size increases. So size increases. What happened due to that? Your ionic character is increasing, and due to that, what is happening? Your carbonate down the group is becoming more and more stable. You got all the points?
Yes. So less polarizing power is much stronger than, more
Like
stable
like
than
we
the
can say
high
like we can
polarizing.
say this is the first member of the group. This is the last member of the group, isn't it? This will be having
Yeah.
more polarizing power, but this will be having less polarizing power.
Yeah.
Okay, so the one which is having less polarizing power, that means that will be more stable. Which is having more polarizing power, that will be less stable. So you can basically say that polarizing power is inversely proportional to the stability. Stability increase, your polarizing will be decreased. Stability decrease, your polarizing is going to be increased. Getting my point now?
Yes, yes.
Okay. Now, let us move to the next one. If we have a question over here, why calcium carbonate is more stable than magnesium carbonate? What answer are you going to write? See, they belongs to same group. Calcium carbonate is more stable, but magnesium carbonate is less stable. So what the answer should be there?
Calcium carbonate has a larger size than magnesium
Very
carbonate.
good. So we can write
This
because this is the question which comes usually. So you have to say that magnesium carbonate Mg+2 has more charge density. We call it as charge, basically charge density. Okay. That means Mg+2 is smaller in size, smaller ionic radius. And what as a result, same answer you will be writing, okay? As a result, what will happen? Magnesium positive causes more polarization. Getting the point? In carbonate
yes,
ion. Okay. And if more polarization, that means more covalent characters will be developed. Therefore, it is easier to break down magnesium. Therefore, it easier to break down magnesium carbonate. Now, stability, what did we talk about? We talked about that when we move down, your ionic character is increasing. Ionic character become more stronger and stronger, isn't it? Breaking of that bond will be difficult. Is not this or no? When
yes,
we
yes.
have an
Yeah.
ionic bond formed, ionic bond is much stronger than a covalent bond, isn't it?
Yeah.
So that is called as stability. As we go down the group, carbonate become more and more stable because they have ionic character. They have made ionic bond, and ionic bond is more stable as compared to the covalent bond. So breaking of magnesium carbonate is easier as compared to break barium carbonate. Got all the point? Are you clear
Yes,
with this thing now?
yeah.
Okay. Now, let us have thermal stability. Heating. Thermal stability. Now we will be talking about nitrate. Thermal stability, group 2, nitrates. Okay. Now, we can say that thermal stability of group 2 nitrates, same as carbonate, increases down the. Okay. Thermal stability of group 2 nitrate increases down the group. Now see how. Okay, I have not done the reactions for carbonate. I have to write that also. Just let me do this and then just remind me that I have to write the reactions for carbonate also. Okay, magnesium carbonate, magnesium nitrate, when you heat them up, what will happen? It is easier to break it. Okay, it is easier. That means you need less heat to break this bond because this is a covalent character bond. So it will be easier to make magnesium oxide, to give nitrogen dioxide, and to give out an oxygen gas. But as you keep on moving down, as you come to the calcium nitrate, what is going to happen? You need more heat. And the reason is now they are becoming ionic. So thermal stability increases down the group of nitrate. That means you need more and more energy to break the bond because ionic character is coming in the nitrates of the compounds. In this way. Getting it?
Yes.
Okay, similarly, I have to write for these also. You can just go, you can just write it as if we have the stability of calcium, magnesium carbonate, this is going to be magnesium oxide plus carbon dioxide. Similarly, calcium carbonate is going to be calcium oxide plus carbon dioxide. Similarly, if you keep on breaking, strontium carbonate is going to be in barium, strontium oxide plus carbon dioxide. Okay, these are the formations which we are going to get. Okay, now same thing which I told you. Now, if I have sodium plus, if I have magnesium plus 2, if I have aluminium plus 3. Now tell me which one will be having more polarizing power. More polarizing power.
Aluminium.
Aluminium, very good. Because aluminium is having more
Then
charge, isn't it? Okay. So polarization is what? Distortion of electronic cloud. In negative ion. Okay. Polarizing power is the ability of cation to attract electron toward itself and distort an anion. That means if the charge will become bigger, so cation has the ability to attract anion toward itself and make that anion to be distorted. Getting it?
Yes, that is only polarization.
That is only polarization. That is only polarization. But you have to, because the question usually this question asked, this is asked about nitrate, about carbonate. This basically these questions normally comes. Okay, this is basically the polarization. Now we will be moving on to electron affinity.
Yes,
Yes, Anna.
Miss, you have written something. You have written something like magnesium carbonate breaking down. What is that for?
Which one? Which one? This one?
Yeah,
Magnesium
magnesium
carbonate.
oxide carbonate.
You see, magnesium positive has more charge density. If more charge density, it will become smaller radius, smaller ionic radius. More charge density mean that the shell is removed and it is having smaller ionic radius. And if you are having smaller ionic radius,
No,
that
Miss,
means
not
what? Yes,
Miss.
and
I'm this part, Miss. Downwards, you have written the dissociation of magnesium carbonate and others down.
association. This one, here, this one. These one polarization dissociations. These one you are calling.
Uh,
This one
you
magnesium
can't see the
carbonate,
screen.
calcium carbonate, sodium carbonate.
Yeah, yeah,
Okay.
yeah.
This was for the thermal stability. I just forgot to write these over there for carbonates.
What is that for, Miss?
These
Carbonates
yeah,
thermostability.
this is for the carbonate. That means as you move down the group, you need more and more energy. Energy is required to break the bond. Okay.
Just like nitrates.
Yeah,
Okay.
I got it. Okay. Now we will be moving on to ability of electron affinity basically. So electron affinity is basically when we add an electron. Electron is added. Electron affinity depends upon your nuclear charge. It depends upon atomic size. It depends upon shielding effect. Okay. If we have sodium, magnesium, there sodium, then we are having magnesium, then we are having aluminium across the period. Then we have silicon, then we have phosphorus, then we have sulfur, then we have chlorine. Okay. If you're moving from left to right, what is happening? This is 11, this is 12, this is 13, this is 14, this is 15, this is 16, this is 17. Your proton numbers, see your proton numbers, but look at your electron numbers. Over here, you are going to have an electron of 10. Over here, you are going to have an electron of 10. Over here also, you are going to have an electron of 10, isn't it? Then over here, again, what happened, you can have an electron, if you do not talk about this one, the size, you will add 4 more, okay? If you will add 4 more, you will have a sharing of 4 more. This is going to be plus 4. Then this is going to be 18. This is going to be 18. This is going to be 18, isn't it? So that means what is happening basically? Over here, you are removing the shells. And if you are not removing the shells, then also if we do not talk about if we do not talk about the ions, we can see if they are just electron, they will be having bigger sizes. But as you come from 14, 15, 16, 17, that means you are having this much arrangement. You are having 2, you are having 8, you are having 4. Your number of electrons are increasing, isn't it? If your number of electrons are increasing, if you are not making them ion, so as in the same shell, your number of electrons increase, which mean that the number of electron increases, which mean that there will be a strong pull. toward nucleus, isn't it?
Yes.
And if there will be a strong pull due to the more electron in the same shell. See, in the third shell, for each of these you will be having in the same shell. This is your second one. This is your third one. See, one electron in the third shell, then two electron in the third shell, three electron in the third shell, fourth electron, fifth electron, sixth electron, seventh electron in the fourth. As more and more electron will be added, as you move from left to right, what is going to happen? Your electron affinity increases, but what happens? Your size decreases, atomic size decreases. Because when you make an ion, now we were talking about an ion, when you will be making an ion, what is going to happen? You are going to add more and more electron, isn't it? See, 18, 18, 18. More and more. Over here you have added 3. Over here you have added 2. Over here you have added 1. So what we can write over here, we can write from left to right. What happened? Electron affinity increases due to the decrease in atomic size. So that means your nuclear charge is directly proportional to your electron affinity. Your nuclear charge increases, your electron affinity increases. What about shielding effect? What happens to shielding effect?
Constant.
It remains constant. So that means this is constant. And what happens to atomic size?
Decreases.
Is decreased. These are the basically properties of when you are having an electron affinity. Okay. This was what when we were talking about the period from left to right. Now in the same group, as we move from top to bottom. Like, let us see that we are having chlorine, 17 electron, bromine, how many electrons? Bromine has an atomic number of
35.
35. Then down, if you come, iodine, it is having of 127, 126, 35, sorry. What is for this one? 54, na?
53.
53. So what is happening over here?
Proton are increase.
Protons are increasing. Your electrons are basically increasing. If your electrons are increasing, your size is increasing, isn't it? See, if we see chlorine goes in 3 shells. 1, 2, and 3. If you move to bromine goes into 4 shells. 1, 2, 3, 4. If you move on iodine goes into 5 shells. So what is happening? Is not your size becoming bigger? So if your size is becoming bigger, what will happen to electron affinity? It will increase or it will decrease?
Decrease.
It will decrease. In the same group, always the size become bigger as you move down. So due to that, what will happen? Your electron affinity decreases. Here is a question over here. Why fluorine has less electron affinity than chlorine. What is the reason?
Fluorine is a very small atom compared to chlorine. So
Okay, so we can write the answer as that fluorine has small size. These are the past papers questions which usually examiner asks. Okay, so I'm writing the question along with that. Fluorine has small size and thick electronic cloud. Electronic cloud is bigger, thick electronic cloud. More electrons, they have surrounded the nucleus. Electronic cloud. Therefore, there would be what repulsion between the valence and the valence mean outermost electron and incoming, and the electrons which will be added and incoming electron. Smaller size do not accept electrons. Bigger size accept electrons easier.
Miss, but smaller size means their nuclear pull will be very high, right? They
Yeah, their
can
nuclear
attract
pull is
electron
high. That
towards.
means positive attraction is higher. So the electron which want to add inside cannot add easily.
Why is
Okay.
it?
The electron which want to add inside, that will not be added easily because your pull of the electron is more stronger to the nucleus, not weaker. If your pull is weaker, then removing and adding electron